My name is Amy Maddox, and this is my Practicum 2 project submission classifying opioid abuse using machine learning. According to the CDC, since 1999, over 750,000 drug overdose deaths have occurred in the United States. 2/3 of these deaths can be attributed to opioid substances. Opioid addiction is a national epidemic which has impacted millions of families in the United States in traumatic ways. There are a wide range of substance abuse data sets available online. I spent weeks prior to the practicum beginning reviewing various sets to determine which set would work for what I wanted to accomplish. I chose the particular data set that I'll talk about in more detail later in the presentation because of the sheer amount of data. And whether or not that was the right choice, I'll also discuss. I wasn't quite sure what I wanted to explore, so I wanted to have the opportunity to look at everything and narrow it down from there. The motivation for this project drove my decision to continue working with this data set, even when it was tedious, time-consuming, and confusing. The overall intent was to obtain specific demographic information on participants, specifically regarding mental health treatment. The project problem or goal for my project is to create a classification model that will determine whether or not a participant is an opioid abuser based on specific predictors. So can opioid abuse be predicted based on demographic predictors such as age, race, gender, income, and location? I also want to determine whether or not mental health has any impact on whether or not a person will use opioids. What are opioids? An opioid is used to reduce a feeling of pain. The most common forms of opioids are the illegal drug heroin, as well as legal prescription drugs such as oxycodone, morphine, codeine, and a few others. This project tracks the use of prescription drugs that are misused, as well as heroin. It is important to note that the dataset tracks prescription drugs used appropriately and prescription drugs used inappropriately. The drugs used appropriately are not included in the target variable. The data set, the 2018 National Survey of Drug Use and Health, was retrieved from the Substance Abuse and Mental Health Services Administration website. It was sponsored by the Center for Behavioral Health Statistics and Quality. Along with the data set, I downloaded the accompanying codebook. This was useful to decode the data set and better understand the survey methodology. According to the codebook, the target population for the survey includes civilian, non-institutionalized populations of the US over the age of 12 at the time of the survey. This does include civilians residing on US military bases. Samples from all states are included based on the population of that particular state. My own observation of the data set reveals that there are 56,313 rows of data and 2,691 columns, essentially a column for every question asked, as well as any imputed data and recoded data for that particular section. I also noticed that the values within the column are nice and clean. The survey uses a standard code convention that is referenced within the codebook. This makes data cleanup really easy and handling missing data simple and straightforward. The codebook breaks the data into sections. Within most of the sections, there are subsections for the actual questions asked a participant, followed by imputed data, followed by recoded data. The NSDUH utilizes a variety of regression and prediction models, which makes up the recoded data. I'll mention this later in the presentation when it's relevant and makes more sense. In order for these models to work properly, missing values must be imputed, which is why there is imputed data in some of the sections. Balancing the target variable. It took more time than it should have for me to settle on a target variable. I settled on this variable, OPINMYR, which is defined in the codebook as opioid misuse in the past year. This is a recoded variable and includes data from both heroin use questions and prescription misuse questions. It does not include data from prescriptions that were appropriately used. I wanted to see data for use that was somewhat recent, not necessarily whether or not a person has ever tried one of the substances. Although if they had tried the substance for the first time within the last year, it would show up in this variable. In reviewing the balance of this target variable, it's quite obvious that it is really out of balance. Only 2,388 people within the survey reported having used one of these substances within the last year. It's less than 5%. I generate a simple bar plot to illustrate just how out of balance this is. Now let's talk about how I resolve it. The model will use existing data within the training set to train the model. Now, while there are some models that will work fine with unbalanced data, it's preferable to have a balanced class to ensure that the results from the model are reliable. I did some research and determined that oversampling is the method that I want to go with. In oversampling, observations from the minority class are copied and randomly sampled in order to balance the data. There are several methods to accomplish this, and in my project, I opted for the rows or random oversampling examples package in R. Using the oversample function, I was able to create a completely new data set with a balanced target variable. This package is terrific. The parameters are easy to set and the function runs really, really quickly, even with a large amount of data. Feature selection using the Baruta package in R. Another issue I ran into with this data set was the large number of features. While I felt confident that I wanted to explore specific variables, I also didn't want to leave out any variables that could be important to the model. For this reason, I researched and tried out the Baruta package within R. The initial cleanup of the data set already helped remove a good deal of columns due to repetitive data that existed because of imputed and recoded information. That still left 866 features to evaluate. The Baruta package is a wrapper algorithm that is built around random forests to help identify important features. The algorithm takes a long time to run, and I ran it twice to really narrow down the number of features. Each time it ran 99 iterations and ended up confirming 66 attributes of the data, rejecting 772 and considering 27 tentative. I used these results to create a new data set. Next, I began work on the exploratory data analysis. I am most interested in the demographic features of the data set. This was an area that was a bit tedious because of the survey coding. Even simple demographics are coded with an integer. For example, the race variable has 7 options and all of them are integers. I referenced the code book to change this to a factor and then add the race categories so it would be easy to determine the race type on the graphs. This had to be done for each demographic category. Upon review of the age category, I can easily see that the data is not normally distributed. The age category with the most volume is 35 and older. This can be easily explained by the fact that the 35 and older category is a wider range than the other age ranges. The gender of the participants appear to be balanced, with the females slightly higher than males. But when reviewing the distribution of race for the participants, I noticed that the number of white respondents far outweigh the number of any other race by a lot. Of the 56,313 participants, 32,761, or 58% of them were white. This is certainly an issue as it can introduce bias into the model. I might want to consider leaving this feature out due to how much the data varies between race categories. Mental illness among adults. NSDUH uses a categorical mental health indicator to score participants' mental health status. This is determined by asking the participant a series of questions regarding their state of mind, such as whether or not they have felt down, depressed, helpless, or suicidal. The responses are coded and ran through a predictive model based on 2012 data to determine what mental health category the participant should be placed into. Most respondents in the survey have fallen into the no mental illness category. The three other categories, mild mental illness, moderate mental illness, and serious mental illness, have much smaller volumes of participants, but you can see that moderate and serious mental illness have about the same volume of participants, with mild mental illness being about double the volume. My assumption when I started this practicum project was that there would be substantially more participants with mental health issues. However, this data collection format is likely not the ideal method to prove this. Individuals with severe mental health issues could be institutionalized, homeless, or unwilling or unable to take a survey in this particular format. I'm adding this to my lessons learned. Building the machine learning model. Implementing the random forest, a tale of two forests. I trained my first random forest on the features that were deemed important by the Baruta package. This resulted in a random forest with an OOB estimate of error rate of 0%. I found this really hard to believe, so I trimmed down the data set by a lot. This model produced an OOB estimate error rate of 1.01%, which is still not believable, but more convincing. So let's talk a little bit how I trimmed down the data set. With the considerations from the first random forest from the Baruta package data set, I wanted to know what a revised random forest would look like with a smaller set of features. I tried several variations. I worked for a couple of weeks trying to trim down the data set and trying different models and running the random forest with different sets of data. A lot of the models almost all of the models ran with 100% accuracy, except for the one with these variables. The variables that I ended up settling on were age, gender, race, income, work status, and location. I also included a category for mental health or mental illness, the mental illness category, and a reason for misusing pain medications. So my conclusion and summary, it's inconclusive. The data set was not ideal for this project. I need data that is more clinical, maybe collected directly from facilities, or some other data set that gives me a more concrete idea of what's actually happening with drug users and former drug users. My lessons learned. I had so many lessons learned during this project. Aside from the tactical knowledge that I attained during the hours and hours and hours of research, I learned the hard way the following. First, it's important to have a solid understanding of the data before spending hours with it. This is pretty obvious, right? This data set really felt like a home run for me. It had all of the elements that I thought I wanted, but I didn't consider the fact that it might not include key populations that may not be able to take a survey, despite what the code book may have said. I was really excited to dig into this data and explore it and look at it from different angles, but I never really took the time to consider what it might look like in a model, which was really important in this project. Check for balance right away. EDA should be the first on the list. I became really tunnel focused on the feature selection instead of the EDA. Had I spent time exploring the data from the start, I might not have bothered with this data set at all. And don't waste time. I spent weeks working on feature selection, and in the end, I didn't even use the data set created by the feature selection function for my random forest. While I'm happy to have learned the techniques, I wish I had spent more time exploring the data and working with the model rather than messing around with something that didn't really benefit the project. Moving forward, I didn't accomplish what I set out to accomplish with this project, but this topic is one that I'm passionate about. I'll continue to search for suitable data, including looking on CDC Wonder, which contains the overdose mortality data and additional data sets on the NSDUH. Once I obtain the right data, I'll reevaluate the data, possibly using random forest or maybe a different model. And at some point, I would like to expand the project. I mentioned in a past discussion post that it would be interesting to see how opioid abusers, particularly recovered users, have been impacted during the COVID pandemic. I would be interested to see if any data has been obtained or released on that particular subject. Thank you for watching my presentation, and feel free to contact me with any questions or feedback.